Hello and welcome to another video. In this video we're going to be working on binary subarrays with sum. And in the problem you're given a binary array nums and an integer goal, and you want to return the number of non-empty subarrays with a sum goal. A subarray is a contiguous part of the array. And so in this first example there are 4 subarrays that have this goal too, so they show it to you here. In the second example you're trying to get all subarrays with sum 0, and there's 15. And this is a constraint, so you want to be able to do this in O(n) or n log n or something. And so this is a pattern that we've done 2 days ago, kind of similar, right? Where we're trying to get all subarrays with some kind of a sum. And now the only difference is there's this goal variable. So instead of trying to get all subarrays with sum 0 and removing them, we're trying to get all subarrays with a goal. And so basically it's the same kind of thing, same kind of idea is, if you do a prefix sum for these, then, like, let's say I do a prefix sum, and when I do the prefix sum, I have the same number multiple times. Like, what does that mean, right? Like, let's say I'm doing a prefix sum, and I get a 2 for some point, and then I get a 2 later on. Well, that means that the whole subarray between these two has to equal 0, right? Because, like, for the sum to be the same, it has to be 0. Like, this whole section has to be adding up to 0, or else you wouldn't get a 2 again. Now, let's say this 2 wasn't a 2. Let's say this 2 was a 4. So if I have a prefix sum of 2 and a prefix sum of 4, that means that the whole section between them has to equal 2. And so that's the basic concept that we're going to be using. And notice, like, this works for any two numbers. So if my goal is 2, and let's say my current sum is like 5, if I have a previous sum of 3, that means that that whole section between them adds up to 2. Now, let's talk about another part. Let's say I have some previous total of 3, and then I have this multiple times. So I have a 3 here, a 3 here, and a 3 here, right? I'm doing some sum, and I have it like this. Well, now I can take my 5, and any one of the 3's, and any one of those subarrays will add up to 2. So, like, this subarray, this subarray, this subarray. So that's kind of the basic idea, is given a total, you're looking for the total minus the goal, and however many times that occurs, that's how many subarrays you have. So let's kind of walk through this example and then this example and kind of understand it a little bit better. So once again, for prefix sums, well, let's just have like a prefix sum over here. And for prefix sums, you want to have all we really need to, we don't really care. Like for the linked list problem before, we needed to care like where it occurred. But here, we don't really care the index of the prefix sum. We just care about how many times it occurs, because however many times it occurs is how many subarrays we have. So initially for the prefix sum, what you want to do is you want to have a sum of 0 occurring once, and that's because let's say this whole thing was like 1s and you're looking for an array of sum 5. So you'd get 5 here, and then you check like, okay, does 5 minus 5 exist? And if you didn't have this, then this wouldn't exist. So this is used to refer to the empty array, or like the whole array being the subarray. Okay, so let's walk through, and you'll kind of see why this is in this case. So we're going to start here. So here we have a sum of, we have obviously like here all the totals are 0. So here there's a total of 0, and we're going to check, have we seen this before? And how many times? We have seen a total of 0, we've seen it 1 time. That means from this point to the other points, we can make one subarray. And we can, right? Like this is the subarray. That's why I said you have to have the total of 0 occurring 1 time. So this is like the first subarray we have, and so we're going to put 1 as the result. Now we just need to take this total and update our dictionary of prefix sums to how many times. So this is 0, so it occurs 1 more time, so now 0 occurs twice. Now over here, our total is still 0, so we ask ourselves how many times have we seen 0 minus the goal, which is 0. Right, so we've seen 0 twice, so that means we have 2 subarrays here, and we do indeed. So this is 1 subarray, and this is 1 subarray, so that's 2. So we add 2. And we take this total and we update our prefix sum dictionary. So we've seen 0 3 times now. Then we go over here, and we have a total again, so we see how many times have we seen it 3 times. So once again, we can make 3 subarrays, so we can make this one, we can make this one and this one. That's 3. So we'll add 3. And we're going to update our total of how many times we've seen 0 to 4 now. And you can kind of see how this is going. So here we're going to see it 4 times. So we add 4 and we update to 5. And here we're going to see it 5 times. So we add 5 and we update to 6. And then we don't have anything else. So this is 15. So that's how you do that one. So if that one makes a little bit less sense, let's go over the next one. And it's going to be kind of the same idea. So once again, you have to start with this. So 0 occurs 1 time because, like, let's say I wanted a subarray that equals 1 and I get a 1 here. I'm going to do 1 minus 1, which is 0, which is this whole subarray. And if you didn't have this, you wouldn't see that. So let's walk through how this is. So let's say our goal here is 2. So our goal is 2. And we're going to keep track of a total variable because, like in this previous one, the total was just always 0, but now it's not. So we'll have a total. Okay. So we're going to start here, and we'll have like a result variable as well. So result, and it'll be 0 for now. So here our total is 1. So we're going to see, okay, well, if our goal is 2, that means we need a subarray that adds up to -1. Or sorry, we don't need a subarray that adds up to -1. We need a value in our dictionary to be -1, because if we had a sum of -1 and now we have a 1, that intermediate, that subarray between those adds up to 2. So we don't have that, so we don't do anything there, and we just update our total. So now we've seen 1 one time. Then we move on. So here, once again, we're at 1. So we check, do we have -1? We don't, so then we just update the total. So we've seen 1 twice now. Then we move on. So now we add 1 to the total. Our total is 2. And now we're looking for a total of 0, right? Because not a total of 0, but an old value of 0, because if something had a sum of 0 and now we have a sum of 2, that means we can make a subarray that adds up to 2. And we do have this 0, and that's why this is needed before. So that means we have 0 one time, so there should be 1 result, and there is indeed a result, right? So 0 occurs over here. That means the subarray from that number to where we currently are adds up to our goal, which is right here. So our result is 1, and then we take our total and we store it in our prefix sum. So 2 occurs 1 time. And you basically just change out whatever you need. So here, if you're looking for a count, you just store how many times it occurs. If you're looking for like the longest length, you store the index of where it occurs and so on. So it's kind of the same problem with a few modifications. Okay, so let's keep going. So here we have a total of 2 still. And we need to see, we're looking for a 0, right? Because we're looking for 2 minus goal. So we have it 1 time, so our result is now 2. And indeed we have one more array here that satisfies. So it's basically, how many arrays do you have that end here that satisfy the constraint that they're equal to 2? And we have one of those, which is this whole thing, right? There's no other array that ends over here. So now our result is 2, so we keep going. And now our total is 3. So if our total is 3, we're looking for the value 1, right? Because we're looking for, if 1 is to 3, that means this whole intermediate part adds up to 2. So we have a 1, it occurs twice. That means we have 2 subarrays here. So we add 4, and let's just check really quick. Do we have 2 subarrays that add up to, that we can have? Yes, we do. So we have this one. And we have this one. Okay, and over here, the total is, oh yeah, but by the way, before we go into the next one, we need to store our sum of 3, so it occurs 1 time. Then here, our total is still 3, so we're looking for 1. How many times have we seen 1? We've seen it twice, so our total should be 6. So we should have 2 subarrays. So let's double check. That add up to 2, that end up with here. So this is 1, and this is 1. So that is correct as well. Yeah, so that's that. Now let's go over here. So our total is 4. So for 4, we are looking, and by the way, oh yeah, I forgot. We need to update this to 2 because our total was 3. So there we go. So our total is 4, so we're looking for a 2. How many times have we seen a 2? We've seen a 2 once, it looks like. Is that correct? We should have seen, yeah, we should have seen a 2 twice. I think that's incorrect. So I think I forgot one of these updates because we've seen a 2 here and here, right? Like this adds up to 2 and this adds up to 2. This should be 2. Okay, so this should be 2, and we've seen it twice, so that means we have 2 more that we can add to the result. And once again, let's see if we can find those. So it's this one over here and this one over here, and anything past that will be more. So our total is 4, so we're going to store that in dictionary. It occurs 1 time. Then over here, our total is still 4, so we're looking for 2. So we have 2 more subarrays that we can add. So 10. And once again, there's this one and this one. And then we update our total for 4. Then we have a total of 4 again, so I'm not going to show the subarrays anymore, but so 4, we have 3 times now, and we have 2 twice, so that means we have 2 more. So 12, and now finally our total is 5. So we're looking for a total of 3. We have it twice, so we add 2 more subarrays, so we get 14. We could show this one actually. So 3, there's this one, and this one. Anything past that or smaller doesn't add up to 3. And finally, you just store 5 with count of 1. And yeah, that's basically it. So this pattern is reasonably common. And once you see this kind of thing, that you can figure out like, okay, if I need a subarray with sum x, all I need to do is figure out the prefix sum, and then I need to look for a prefix sum of my current total minus x. However many I have there, like let's say this was 1, this was 1, this was 1, then you can just make all the subarrays. So like this would be a subarray, this would be a subarray, and this would be a subarray. Basically the subarray is the previous prefix sum, every number past that till the current number. So if you're matching with this number, it's going to be over here. For this number, it's going to be the one past that to the current number, and here, the same thing. So we can code that now. I think that's a good enough explanation. So let's do a prefix sum. So we'll say, let's do a default dict, I guess. So prefixes equals default dict integer. And we're going to, like I said, we're going to give a prefix of 0 a count of 1. So prefixes 0 equals 1. Now we need to keep track of a total. So we'll just say total 0. And we'll just say for num in nums, total plus equals num. And the number we're looking for is the total minus goal. So we can say if total minus goal in prefixes. Oh, we also need a result variable. Then result plus equals prefixes total minus goal. And finally, we store our current total. So prefixes total. And we can return, and that should be it. So let's take a look. And there we go. It's pretty good. So yeah, it's definitely one of the more confusing patterns. Like I was actually explaining this kind of thing to someone a few days ago. It's definitely pretty confusing when you haven't seen it before, but once you see it, once you just like get it in your head enough times, you're like, okay, I get it. Like it's pretty straightforward. So it did take me a while to like understand it. I think there's literally a problem that's like subarray sum equals k or something, which is basically this, except your numbers aren't binary, and it's the exact same solution. So you can link into that one. I'll link that one as well, if to further your understanding if you need it. So yeah, for this one, it's going to be of n, because we're going like left to right, one pass, and then the space is going to be of n as well, because like let's say all these numbers are like 1 or something, then you can get n different numbers in your prefix sums, so that's going to be of n. And yeah, it's going to be all for this one, so hopefully you liked it. And yeah, if you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.